So we're looking at chemical energy today. And chemical energy is a type of potential energy. So we have kinetic and potential energy. And potential energy is stored energy. And the stored energy comes from the bonds, the chemical bonds between each of the atoms. So there are two different ways that energy can be explained, either endothermic or exothermic. Endothermic is where energy is going to be taken in, and this happens when bonds are broken apart. So molecules like to be bonded together, and then when we break those bonds apart, we're forcing those individual atoms to separate, and they don't want to be separated, they want to be bonded. And so we have to force them apart by adding in energy. Whenever we have a chemical equation, we're going to have energy in the beginning of an endothermic reaction. Then in an exothermic reaction, energy is given off, and that's when bonds are made. And if you have an exothermic reaction, it's going to be written as a product. So it'd be CH4 plus O2 gives us water, carbon dioxide plus energy. So energy is one of the products in an exothermic reaction, and it is one of the reactants in an endothermic reaction. And so in order to get bonds to break apart, we need to add in energy, and we call this activation energy. And this is an endothermic process. In every single chemical reaction, there is some energy added in, because in every single chemical reaction, you must break bonds apart. So here is some energy being added in to take this methane molecule and these two oxygens and separate them into their individual components. Remember, atoms don't like to be separated, they like to be bonded together. So we force them using energy to separate. Then what happens in a chemical change is those atoms rebond and form some new bonds, and in that process, they give off energy. So when we have these separate molecules or separate atoms all coming together to form new molecules, in that process, that's an exothermic process because energy is being given off. And so in every single chemical change, you have energy added in to break the bonds apart of the reactants, and energy given off energy is given off when the new products are forming. So every single reaction is like that. And so what we have to do is we have to figure out, well, did we have to add in more energy, or did we have to was more energy given off in that reaction? And that will help us determine if we have an endothermic reaction or exothermic reaction. There's some energy added into every reaction, there's some energy given off in every reaction, and all we have to do is compare those two. So overall, to determine if a reaction is endo or exothermic, we always are comparing the energy added in to break the bonds apart with the energy given off in the reaction when the new bonds are formed. So if you have to add in more energy to break those bonds apart than what you got when the bonds were forming, that's considered an endothermic reaction. If more energy was given off when you formed the bonds than what you had to put in to break them apart, then overall your reaction is exothermic. So you have some energy added in and some energy given off in every single reaction. All we have to do is compare the amounts. Did you add in more energy, or did you get off? Did it give off more energy? And so depending on which one is greater, that will determine your overall energy involved in the reaction. So this graph really helps us kind of figure that out. If we look at step 1, right here is our energy level. So we're kind of a lower energy level. And so these are our reactants. And so what we're going to do is we're going to add in energy. And so the energy is increasing, it's going up. We're going to add in energy and we're going to break these bonds apart. So this step 1 is an endothermic process. So we're breaking those bonds apart. Then step 2, we're going to form some new bonds. So we're forming the products. And so this step 2 right here is an exothermic one. So energy is being given off. And so what we do is we just compare step 1, breaking the bonds apart, to step 2, forming the new bonds. Whatever one is greater is going to be the overall type of reaction. Step 1 and step 2 are part of every single chemical reaction. It's just to figure out the overall energy, we have to just compare step 1 to step 2. So step 1 is the energy we put in, also known as activation energy. And step 2 is the energy that we get out of the reaction. So if we look at this particular reaction, this one would be considered exothermic because there's more energy that we get out on step 2 than what we had to put in. So if we compare, we start here and go up to here, that is a smaller amount than if we go from here to here. So this is a larger amount. So exothermic was the larger amount, so therefore it's an exothermic reaction, so we would write this as a product. So if we wanted to draw an endothermic reaction, we would just have to make sure that we drew this where you'd have a longer step 1, so that line would be longer, and then a shorter step 2. So that overall you would see that, oh, step 1 was the part where I had to add in that energy, and that would be an endothermic reaction if you had to draw that one. So if we look at a little quiz on some energy questions, number 1 says, overall, if energy is added, what type of reaction would that be? And as you can see, we have endothermic is highlighted here, so that would be correct. So if you had an endothermic reaction, overall, you put in more energy than what you got out of it. Then number 2, does a combustion reaction require energy to be added in? Yes, every single chemical change requires energy to be added in because we still have to break those bonds apart. So if you think about a combustion reaction, things don't just start on fire by themselves. You always have to add in a little bit of energy to get that fire started. So you have to light the match, or in the lab, we have to start the sparker, or the striker. So we have to always add in some sort of spark to get the combustion reaction to start. And that is that little bit of activation energy that we put in to get that reaction to go. When bonds are broken, energy is added. So that's always that activation energy. That's always an endothermic process to break those bonds apart. It doesn't matter what type of reaction it is. We always have to add in some energy to break those bonds apart. Then when we form the products, that releases energy in every single reaction. We release some energy. Remember, to figure out if it's overall endothermic or exothermic, we just compare how much energy did you put in when you broke the bonds to how much energy was given off when you formed new bonds in the products. Then every chemical reaction involves energy being added in because that's going to help break the bonds, energy being released because that's what happens when bonds form, and of course conservation of mass, which comes in when we're balancing equations. So all of these are involved in every single chemical reaction.